To help us really get a good understanding of piecewise functions, we're going to take a look at an example here related to the cost of first-class mail letter postage. So it turns out that in July of 2022, the cost of a single stamp for first-class mail was 58 cents. But that's only up to the first ounce of weight. So as soon as you start packing more papers or things into your envelope and it starts weighing more, they start charging you just a little bit more. So it turns out that it's going to cost you 24 cents for each additional ounce, but they're only going to go up to 3.5 ounces of weight. So as soon as you exceed that, they kind of start charging you a little bit differently than that pattern. So we're just going to restrict ourselves to this pattern up to the first 3.5 ounces of weight. So we're going to take a look at the relationship between the weight of that letter and then the corresponding cost, and this will help us see kind of an application of piecewise functions as well as what they look like here. So we know that the initial cost of a letter, if the weight is between 0 and 1, and I put it in the second row purposely here. So if the weight is between 0 and 1, so if I write that compound inequality there, but I think we could put an equal to for the 1, because if it does weigh exactly 1 ounce, it's still going to cost you 58 cents. Now I put that right there to be a strict inequality, because if the weight was exactly 0, then the cost would be 0. So that's why I started in the second row there. So if we continue this pattern here, so if the weight is above 1, so a strict less than right there, but then we can make it equal to 2, then it's going to cost you like 24 cents more. So that's going to be 82 cents, and then it costs you 24 cents more, which is going to bring you up to $1.06. And that would be if your letter is between 2 and 3 ounces of weight, and then it'll go up another 24 cents to $1.30 as soon as you get above 3, but then right here this is going to go up to 3.5 cents. They only go up 3.5 ounces. All right, so with all of that then, let's take a look at a graph of this relationship. So let's choose the x-axis to be the weight of a first-class letter in ounces, and then let's let the y-axis be the corresponding cost, which will be in dollars. And how about if we count by 10 cents, so that would be 50 cents, 60, 70, 80, 90, that'd be $1, and then there's $1.20, so we'll have to go a little bit above, but that's okay. And then in terms of weight, let's maybe just put 1 right there, and 2 ounces there, 3 there, and 4 there. Excellent. All right, so if I start graphing this piece right here that I just circled, so it turns out that whenever W, or the weight, is between 0 and 1, it's going to cost 58 cents. So that basically kind of means that, like, right there, we're just going to kind of have a flat horizontal line at 58 cents between 0 and 1. But I'm going to put an open circle on the left end and then a closed circle on the right end, corresponding to when and when cannot the weight be certain values. And then if I graph now that first little point right there, we're just going to have kind of a random dot down there at 0, 0, because when the weight is 0, it turns out the cost is also 0. So if we just kind of keep going between 1 and 2, it's going to cost you 82 cents. So that'd be like right about there, and then you put an open circle and a filled in circle, and then next it's going to be $1.06, so that'd be like kind of right there-ish. Again, the same circles, and then finally it's going to cost you $1.30. It's going to go a little bit higher, somewhere up there, and that only goes to when you're 3.5, so it's going to be kind of a little bit of a shorter segment right there. All right, so that gives us the graph of what's going on right here. So knowing the weight of your letter will tell you exactly what the cost is just by kind of looking at the graph. And this is an example of a piecewise function, which I'll kind of define in a little while here. Really just a graph that's going to be kind of in different pieces. And so the way that we can represent piecewise functions by writing a function is going to be as follows. And so when we write an equation for a function like this that's in different pieces, you're going to have them grouped together with a left brace. Now it kind of makes it look like a system, which kind of sort of is, but really we're trying to write an equation here. You can see I have an equal sign before, and we'll have something kind of go before that in just a little bit. So let's define the cost to be like your y value, because the cost is going to be determined by the weight. And so let's let the input variable be w. So c of w will be kind of our function. And so it turns out that the cost will either be equal to 0 or 58 cents or 82 cents or $1.06 or $1.30. So it equals one of those 5 different things, but not all at the same time. In other words, it wouldn't be a function if it equaled multiple y values for the same input. So we want to specify when or for which w's it will actually equal each of these numbers. So I put commas to separate, and so I'm going to say that when w equals 0, then we do have a cost of 0. And then when w is between 0 and 1, excluding 0 but including 1, and then just going based off what we just did previously, let's see, that should be a 1, that should be a 2, and then from 3 to 3.5. There we go. So these right here really specify kind of the parts of the domain, or the set of the inputs in which you're then going to map to those particular outputs. And so what we see right here is kind of your first example in terms of how we can write equations for piecewise functions. So what we're going to do from here is just kind of formalize what piecewise functions are, and then really dive into more aspects of piecewise functions.